graphing on the computer and doing something new. So we got to have some new skills developed in here. When we opened up systems of equations, we said that we really didn't want to put a lot of emphasis in solving a system of equations, because trying to read a solution off of the graph is not really a very easy thing to be able to do. But now we're going to be dealing with inequalities. And that means we're going to be seeing things like this. 3x plus 4y must be less than or equal to 24, something like that. We're not going to be seeing equations, we're going to be seeing inequalities. And in an inequality, it's not one and only one value that's correct. There's an infinite number of values that are correct. For example, if I were to tell you, I need to find two numbers that will add together to give me 10. There are an infinite number of possible combinations when you consider positive and negative. So inequalities give us an infinite number of solutions, which means we can put a graph grid out, because now instead of looking for the single point of intersection, we're going to be looking for a whole region of values in a problem. So here's the dynamics of the problem. Since we're going to have inequalities, we got a three-step process. First thing we have to do is determine where the line is going to be positioned. And we're going to be using, for the vast majority of the exercises, intercept concepts to be able to get our graph. Which means that the vast majority of the problems will have both of these coefficients dividing that nice constant value. So you will get nice whole numbers. There is the occasional fraction, but if they give you a fraction, they have to give you a grid large enough to be able to plot a fractional value. So they would give you 1 and 2 with a grid line in between if you needed a half unit somewhere along the line. After we determine where the line is positioned, we need to determine whether the values that are on the line actually satisfy conditions of the problem or not. Because if they do satisfy conditions of the problem, then the line itself is acceptable as part of the solution set, up to and including that value. But if they're not acceptable, then it's only up to but not including. So the difference is whether that line becomes a solid line on the graph that we put in, or whether it becomes a dotted line. Another choice that we'll have to make. Then we're going to have to find out which side of the line we are actually going to get our shading on, and that requires a new tool, but that's also going to require a new technique called a sign test, which is really just a basic arithmetic operation that we do. So those are the three steps. So step number 1 is going to tell us if we want to graph an inequality in a graphing grid, we are going to have to, first of all, find out where that line is positioned, which means we're going to treat the line as though it was an equation. We're going to find the intercepts. The intercept life is going to be easy because letting x equals 0 means that whatever this is turns out to be a 0 value. 0 added to something doesn't change anything. So letting x equals 0 removes x's effect from the problem completely, putting all the work on y, which gives us a y-intercept. Letting y equals 0 will do the same thing. So we can almost get x and y intercepts without having to do any paper and pencil work by just covering up one of the existing values. But still, might be a good idea to put those intercepts down on the paper for a test type of situation. It's not like you have to do the work in the problem. In other words, what I'm saying is, if I say that I want to let x equal 0, I really don't think I need to see this step in the problem. I really don't think I need to see this step in the problem. At the absolute worst, I would need to see this step in the problem, because it would tell me that the y value then is going to be 6, which means that since I let the x value equal 0, the y value is 6, and there's one of the 2 points that we need to graph. So the work that you do to find the intercept is much more done up here than it is over here. If anything, this would be what you would give me in terms of support work for a problem, if anything. After we decide where the line is, then we have to decide whether we're going to have a solid line, and that's real simple in terms of a visual. If your inequality is a less than or equal to, or a greater than or equal to, then the line is included and it goes down as a solid line. If it simply says it's less than, then it's up to a not including, or greater than, not including, then it comes out as a dotted line on a graph. So that's another choice we'll get to make. Then we'll have to find out which side of the line is going to be shaded. And to do that, we're going to pick a point that clearly lies on one side of the line or the other. We're going to drop it back into the inequality, and now we're going to use this inequality to find out whether the statement is actually a valid statement or not. If that point satisfies the inequality, then we know that it, along with all of its friends on that side of the line, are solutions, so that entire side of the line will be shaded. If it's not satisfying the inequality, then it and all of its friends are excluded, and it's the other side of the line. So one simple point test can tell you which side of the line you have to graph. It doesn't have to give you a true statement, because if it's not true, then the other side of the line is the part that has to be true. So what that means is that in print, in a workbook exercise, we might see something like this. I didn't want to do that. I want to do this. We might be something like this that asks us to be able to solve or graph and solve this inequality. In your workbook exercises, and the workbook exercise for this won't be due until next week. By the way, cryptography is due for us on Monday. The homework set is due tonight, I think, and then the quiz is due tomorrow. So in here, my support work for something like this would be probably looking a little bit like this. If I let x equal 0, then I'm going to get an ordered pair that looks like this. If I let x equal 0, then there really is no reason for me to even write this part of the statement, because I know it's going to become 0, and I know that 0 plus 3y is going to leave me 3y. So basically, letting x equal 0 means that x gives us all voice of say-so in the problem, and all the emphasis is set on y, and that's why we can just kind of cover it up or look at it and figure out what the y-intercept is pretty easily. So the y value here would have to become a value of 2. So 0 and 2 is one of the points that we have to graph on our grid. 0 and 2, if I have a 10-unit grid, which this particular one is, all the grids on the program are labeled for you. Grids in the workbook are not labeled for you, and you have to decide what scale you're going to use to make it fit in the graph. Then if I come back and do the same thing and said, well, but I didn't have to let that, I could have picked y equals 0 in the problem, and if I let y equals 0, then I know I'm going to have a 0 for that part of the problem, and once again, it would be really unnecessary to do this, because I know that I'm going to get a 2x plus 0 equals 6, and that means that I'm right down to having just 2x is equal to 6, so x turns out to be a value of 3. 3 and 0 would be the second point that I would have to graph. On paper, we would then take a straight edge, because some of you can't draw straight lines to save your life. I'm one of those people too, so. And we would connect the dots, but we wouldn't stop just between the two dots. We would extend beyond the dots. Now that tells us where the line is. This inequality here tells me it has to be a solid line. If it were just less than, then it would be a dotted line, and I would have to do something like this. I'd have to have some sections taken out of that line. If it were a dotted line, it would be this on the paper, and it would be one of our choices for the computer. So let me put all those things back in there again, like I wanted to do. Now the new thing to us, other than graphing, because we've already seen the graphing side of things, the new thing is being able to find out which side of the line is going to satisfy the conditions of the problem. So you're going to be asked to pick a point that does not lie on the line. It must lie clearly, either in this case above the line or below the line. It doesn't make a difference what point you pick. Pick something nice to work with. So keep your numbers small. Most people are logically going to pick positive numbers, so they don't have to fight with negative numbers, but that may not always be an option for you sometime. So Pick a point. This is your choice. What do you want to test?
3, 2.
3, 2?
Yes.
Clearly lies in the section above the line, right? That's your choice. Wonderful. So the question you're asking yourself is 2 times the x value that you chose 3, plus 3 times the y value that you chose, which was 2, less than or equal to 6. That's either a yes or it's a no.